Hello. So I just wanted to do a quick video about WASM-4, which is a fantasy console using WebAssembly. If you don't know what a fantasy console is, maybe you've heard of Pico 8, which is a fantasy console with Lua, which basically the concept is you get like a limited screen. In this case, it's 160 by 160 pixels, and in this case, four colors. In Pico 8, it's more than that. I think a bunch more. It's like a fixed palette, whereas this you can like configure. It's just four at a time on the screen, but basically it's like kind of comparable to a Game Boy, but with made up hardware. And in this case, the hardware is WebAssembly, which is really cool because that means like you can compile all kinds of languages to it. So assembly script, Go, SIG, and of course Rust. So um, I did started to make a small game with it, and yeah, just wanted to quickly show that. Um, So the game I wanted to make is like a clone of old. I don't know if you can hear the audio, probably not, of this old Flash game, which you can now play on archive.org, which is like with an WebAssembly emulator of Flash. Basically, uh, you can spawn units and stuff, and then in the middle they'll like just collide with the enemy, and yeah, it's like a really popular old Flash game. Well, anyway, yeah, so I wanted to make a copy of that. Maybe let me first show you how far I am. So by pressing R, you can just reload. So the enemy automatically spawns units, and yeah, there's two types of units. There's ones with guns, and then ones that just do punching. And currently the enemy just statically spawns a bunch of units at the start, and then that's it. And you can spawn. Currently, I was like building in some buttons to spawn units, but also with X and Y on the keyboard. Or I think on an American keyboard it would be X and C, maybe. I'm not sure. Um, well, anyway, so let me show you what that looks like. So you can set there's this command line utility for it, which is W4. And with watch, it'll like do the cargo build thing and automatically rebuild when you change files. And the rebuild is actually quite quick. I mean, probably it would get slower quite fast if the project size or like compile complexity expands. But yeah, currently it's still quite quick. And this is actually a case where you need to do some unsafe. Um, well, actually, maybe so in the official tutorial, they use a mutex for state. So basically, the idea is you get a start function and an update function, and um, because it's not like usually in Rust where there's one main function, you actually on start you initialize your state and then update gets called every frame, so approximately 60 times per second. And so when you look at like the tutorials for other languages like SIG I looked at, they just do global state and that's fine. In Rust, it's not quite that easy. And in the Rust tutorial, they use a mutex, which I think is quite wasteful because it tries to lock, and that's just unnecessary because in this case, it's guaranteed that start is called first, and there's only one update running at a time since there's not even really multi-threading in WebAssembly. So I just did maybe on init, which basically is a variable that can be not initialized, and then you can like initial at the beginning it's uninitialized, and then you can write to it, and which is I believe unsafe. Wait, let me see. Oh, it's actually not. You can just override, which is interesting because if you just overwrite it, well, I'm actually not sure. Is it really not unsafe? Ah, right. You can just overwrite it, and that doesn't drop what's previously in there. So, but since dropping isn't guaranteed in Rust, that's actually fine. So I guess, yeah, that's safe. But so I guess I could like move that out. Let me see. Use of mutables. Ah, yes, of course. It has to be unsafe still because we're using static mutable. So um, yeah, for that you have to be unsafe. But then we can just go assume init mute, which gives you a mutable reference and is obviously unsafe because it could be uninitialized. And then we just call update. So like this is the unsafe part, and then you also have to use unsafe for setting draw colors. So draw colors is just like when you initialize a WASM-4 project, you get this like it generates you this file with like bindings to the console. So the WASM-4 virtual fantasy console like has at fixed addresses. There's like stuff, for example, you can write to them for setting colors, which is like the colors currently on the screen, or the palette is no, draw colors is actually used by a bunch of drawing functions, and then palette is which four colors are actually on the screen currently, and then you can like get gamepad input and so on. Right, and so for the setting draw colors, I just wrote a wrapper, and then my main thing is like the game structure, which has this new function, and yeah, so it's actually relatively simple, which is actually what makes this sort of game really interesting because you can like, I mean, I did a few things a bit awkwardly, but like basically the concept is you I have player units and enemy units, and they just have an X position uh, because it's basically one-dimensional sort of. And the camera has a position, and then there's the health of the bases. And then each unit basically has a unit type, which is just static, has like references to animations. Animation is just like a slice of bytes, which is for painting. Then speed, health, range, and damage. I don't know if I'm using all of them yet. And then like there's a walking animation and an attack animation. Standing currently isn't because I'm pausing the walking animation, so it doesn't like reset all the time when a slower unit walks behind the fast. No, a faster unit walks behind a slower unit. Like whenever it, because when they're within range, they just stop, and if I then reset to standing uh, all the time, then the problem is like they never actually animate. So I had that problem where like if I had a faster unit behind a slower unit, they would just like be in standing animation all the time and move, which is obviously not. I don't like my solution because it means I can't like have a nice idle animation, which I don't know. Yeah, but like the fun thing about this is like you can just do really simple stuff and get some cool results you can like play with. So it's actually uh, for me it was quite like therapeutic, I would say, because it's just like a fun programming project where like it doesn't matter if you do things messy or just hacky or whatever, you can just do whatever. Yeah. So by the way, I'm using a vec DQ because I'm adding units to the end of to the end of a list. I want to add units, and like when they get killed, it's usually at the start. So just using a normal vec would be suboptimal because it would have to like move the content of the entire list a lot. So I thought I use a vec DQ, which is basically like a ring buffer, which, yeah, if you have to delete something from the middle, still like has to move stuff around, but it'll actually move whichever end is closer. So that minimizes like, uh, yeah, unnecessary like copying stuff around. And so, I mean, I'm not fully sure whether that's like the best data structure, but yeah, it's just my my guess. I haven't actually benchmarked. Um, but yeah, the other option would be a linked list, but I think a linked list or a doubly linked list, I guess. But that would be suboptimal because memory fragmentation, basically, because each entry has a separate allocation, and like especially with limited memory, uh, heap fragmentation could become an issue. And also just like adding new stuff will like be an allocation all the time, which could be a performance issue as well. But yeah, all of that is with like the caveat of like I haven't actually done any benchmarking or anything. This is just based on my understanding of these data structures. Yeah, so I don't know what else. So for buttons, you can basically see it's not like in other, like usually when working with GUI stuff, you get events for when the mouse is down or up. In this case, you can just actually look at the current state of the mouse. So to actually detect a click, or even a like also with buttons, you have to like save the last state, which is why we have in game state we have these button states. I'm not using all of them currently, but and then you have to compare to the last one. So basically, I'm saying if where is it? Yeah, if previous button was up, I was down, so true is down, and now it's not down. That means it was just released, and then we can do the action we want on release, which is usually like with a lot of buttons, it's you want to do something when the button releases, or I guess when it goes down, but you don't want to like do the thing in each frame where the button is down. Unless in certain cases you can also do like some sort of cooldown or something, which also works, but mostly this is what you want. Sometimes you also want, yeah, to do stuff when the button goes down. Uh, yeah, it's actually an interesting topic because in a way it's really weird that like in GUI or generally in software, the convention seems to be that like stuff happens when you release the button or the mouse button or whatever. And with physical buttons, it's usually stuff happens when you press them down. But I think the release thing is there because, like, for example, for drag and drop, like, if the action happens as soon as you press the button down, then like you can't wait and see whether like the user moves the mouse a bunch. And yeah, I think that might be the reason why the convention is on button release. Mm, I I think I did some experimenting like a long while back with that, and like it feels really weird when you do a GUI and stuff happens when you click down. It feels like stuff happens too early because like we're all used to stuff happening on button release, but I think you could actually trick some users into thinking, wow, this software is really fast when stuff happens on button down. But yeah, that's just like psychology. It's also like this meme where like people will think, I don't know if that's actually true, but it's a joke where like you say you speed up the mouse and like people will think the computer is faster. Right. So yeah, so basically this is just I think typical game type programming where like the updating code is mixed with rendering code, which means you have to loop over everything like only once. But yeah. Um, so actually, so there's the problem, the downside of doing that is like frame tearing, which basically means like you render the thing at the state it was when you were looping over it, but like within the same frame, stuff also gets mutated. So like, yeah, that's just an effect this has. But like with games, that doesn't matter much. I think there's very few cases where you care about that because like you get 60 frames per second. Like if there's a torn frame, next one will be right again. And like, yeah. So yeah, so maybe an interesting thing is like my update unit function uh, is it gets the unit, it gets the last unit, which is like the unit that's walking before it because it needs to like stop when that one stops and so on, and then it gets the enemies. And now there's this ugly thing of like forward and like it walks in the opposite direction, renders mirrored because like the enemies, uh, so the AI basically gets false here. And like I'm not so happy about that because like there's a bunch of ugly stuff with that. I'm sure that can be solved better, but also like it's such a small project that it doesn't really matter. um yeah, so maybe sprites are also interesting. So since the screen can only show 4 colors at a time, and the sprite format, there's one with like only 2 colors, which is basically black and white, or no, not even black and white. It's one color and the other transparent, so you can use like a bit per pixel, which is really compact. But if that's not enough, there's one with 2 bits per pixel, so 4 options. But since one of them is transparent, you actually have to choose the 3 colors you care about in a sprite. Now, you could do your own format where you use more bits per pixel, but then you can't use the built-in functions. But yeah, anyway, so I did a bunch of like units. You can actually, yeah, this black stuff I think is just part of VS Code's transparency thing. It's not actually there. Um, but yeah, you can see like the frames. And I did them with a Sprite, which is unfortunately a proprietary tool, but I think it's quite cheap. I don't remember how much it costs, but you can get it on itch.io. And then there's this built-in thing, W4 PNG to source, which I think only works if your PNG is a indexed, which means instead of storing RGB values, there's like an index which says which number is which color. And then you can like use one where there's only 4 colors in the index. One of them is transparent. And then with that, like you can generate the sprite. It actually generates code. So that's this sprites.rs. So in my case, for each has width, height, flags, which I'm actually never using, so I could remove that. But for the base, I'm actually using it. But the flags is basically just for the blit function, which it tells it like which format it is, and also whether to mirror. But actually, I'm just adding that in code, obviously, because I'm using the same sprites, mirrored and not mirrored. And yeah, you can actually specify a template because the default Rust one doesn't make things public. So I did this. It's a mustache template, and then yeah, it just loops over and like generates the file. I think it's a bit weird to do that in Rust, like to use a bash script to generate code. In a way, it would be cooler to like have a procedural macro, or I don't know, or even just like include bytes maybe, but then PNG would be too expensive, like use too much space, because the number of bytes per like card, they call it a card, the build WASM artifact is limited to, I think, 2 to the power of 16 bytes, yeah. And so actually it's quite easy to be over that. So my game, if I don't strip the symbols, is actually a good bit over that. But when I strip the symbols and do link time optimization, then it's actually a good bit under. But like you have to be careful, which also makes this whole thing fun. Like you can't do really large games. You have to do something simple. But yeah. Yeah, so anyway, maybe I hope that was a decent introduction. I didn't like fully explain how this works, but I'll link the GitHub of it. It's called Age of WASM because the Flash game is called Age of. I probably said that, Age of War. And yeah, you can check it out, and if you want, you can make a pull request, adding something, or yeah. Okay, see ya.